Here's your pre-calc lecture for 11.1.3. It's families of polar functions. So your book just meant this, I think, to get you interested in other polar functions. In the last couple lessons, we learned that r sine theta and r cosine theta um, look like circles, like when we graph them on a polar when we do some polar graphing with those. I think we saw some of those ones that made flowers, and I think I showed you that on Desmos. All of this is supposed to be kind of an investigation. I'm going to include a video where it's an hour-long video by a different teacher who just spells out every single thing about these. But my little lecture I'm going to give you is just, I would hope that you would want to go on Desmos and just put these in there and start plugging some numbers in for them. That's kind of what I did with it, and I'm going to share that with you right now as I share my screen. I hope to share my screen. I hope this turns out where you can see my screen. So the only one I couldn't get was the very last one. But so these ones, I just went and I typed in what they suggested in your book, and I saw that the first one gave me what we call a spiral. And I was able to actually get Desmos to give me these slider bars. So I could, if we were in class together, you guys would probably be using Desmos, and you would be trying to figure out, oh, I wonder what K does. Does K make it, does it tighten the spiral or loosen it, or does it change direction? So I would encourage you to get your own Desmos. You can get it out on your phone, or it was easier for me on the computer today. And then you can just look around. I always think of like x minus h. I always think of this as a horizontal shift, so I was wanting to see if that's really what it does or not. So you're not going to be tested on any of this stuff, but I hope that you think it's pretty interesting, and I hope that you'll check it out. And then n, let's see what n does. Whoa. So please check this out on your own. So that first one, letter A in your book, that was family of spirals. And then, whoa, wait, what's this? Oh, I see. I could have let it just go automatically, right? Let's go to the next function. So this is just a circle, right? R sine theta. Was anything interesting? I think something interesting happens. Sometimes you get let's see what happens if I change 8. Oh, wait, I had a slider bar. Oh, let's see if anything interesting happens. Oh, well, you might find that interesting. And then what happens with A? Oh, A is the radius, right? Okay, so you might have already known that from last time. And then I could do the same thing with cosine. Cosine always, the circle is going to be kind of over here somewhere. I actually have a lot of these to get through, so I'm not going to show the cosine one, but, oh no, actually I will. I'll just type it in right here. You guys can, oh, hey, looks familiar. See, it just moves it so that it's straddling the x-axis if it's cosine. This one, very interesting. I was thinking about H and K when I did this, like our H and K that we have that gives us vertical and horizontal shifts, but we're in a polar, not rectangular. So H and K do some interesting things. Let me get rid of this other graph. So, and I watched the video. There's a video that it's an hour-long video. I watched it just to see Like the guy on the video, if you don't want to investigate this on your own, he'll just tell you. He'll come right out and tell you what everything does. Whoa. Interesting. Hey, what if I go? Oh, oh, that's because it's multiplying it by 7. I have to put the plus sign in. I hope you have as much fun doing this as I have been having. Yeah. So, this thing is actually called a cardioid when it's like this, when it has this little dimple in it. And I guess I should name some names. Um, they're called cardioids and limesons. So a limason will have a little loop in it. How can I get the little loop to come out? Let's see. Oops. Okay, let's use these. Oh wait, I think it's the next one. The next one will give us. So this thing is shaped like a heart, so it's called a cardioid. I'm actually going to put a Vi Heart video up there for you too to look at. Let's look at this. Oh, look at this one. This one is a rose, I think. Let's see. Yeah, this one's called a rose. If I take this out, let me take the 4 out of there. This thing right here, when it looks like this, oh, you can't see it. Let me make this go away. When it looks like this and it has a little loop in it, that's called a limason. If you watch the video that I keep telling you about, the hour-long video, he'll go through every single one of these different things. But when it's like this, that's called a rose. And I just, again, hope that you will, I hope that you will go through and you'll think this is pretty cool and you will check this out on your own device. So there's that, because that's what we would have done if we would have been in class together. Now this one, they used secant. There's other ways to get this, but this is called a lemniscate. It looks like a kind of like a sideways figure 8. Okay, and you don't have to use secant to get this. You'll see, I think in your homework, you're going to get one just with cosine squared theta instead of secant. And this thing, I don't know if you can recognize that. That's what I used to make this this square root. This is number 5 in your book. If you're looking in your book on page 484, it's called a lemniscate. And so, a little less interesting than the rose. This one right here, you might recognize this as a hyperbola. And then if I change this value, now it's an ellipse. Let's see, if I change, let's see. I mean, it's a circle, but let me give it, see, like, if these two coefficients right here are not the same, then you'll get the elliptical shape. And then if you get a negative sign, like if I put the negative sign here, it's going to go out to the side. Okay, so there's that. So that's ellipses and hyperbolas. And then this is a cissoid of Diocles. And this one I don't think he talks about it in the polar graphing video that I put up for you, but this one it just has a point right here and it goes off this way. And what else? I could do stuff to it. I guess I could change it. I could put positive 2, right? And you can move this around. This bottom one here, I wasn't, oh, otherwise use parentheses. So if anyone wants to see if they can type that one in so that Desmos will show it, I think it's going to look like a little loop-de-loop though. And that bottom one is called Folium of Descartes, like Rene Descartes. Okay, so I think that's all I really have for you. I'll go back to our book right here. I hope it recorded all that. You guys are going to have to do, the only thing from here that you're really going to have showing up in your homework is just some investigation problems. And there's one investigation problem where it ends up being a lemniscate. And it's right here on 11-47. How are you ever supposed to know what to do when it says investigate? Well, what it wants you to do is put it in Desmos and investigate it. And then you're probably going to find out that it looks like a figure 8. Or you might say it looks like an infinity symbol. And then you can describe, if you can figure out what A controls and what R controls by messing around with Desmos, then you just describe it right there. And that's all I got.